moving into section 4 with polynomials. A lot of this should, again, feel like a review. Mostly Algebra 2 review on this section in particular, because we'll be combining a lot of terms, we'll be shifting terms around, we'll be seeing a few different ways to add and subtract polynomials, multiplying polynomials. If you've had me previously, I will be using box method to show that work, which in my eyes is just another way to FOIL, which might be what you're more used to. So we will see mostly box method. I may switch it up to FOIL, I'm not sure yet. Of course, if you have any questions on box method or foiling, please let me know. We'll also be using special products and polynomial multiplication, so a different type of multiplication where sometimes there's a bit more going on. You could think of this as an enhanced form of box method. So there's a little bit more going on there. Also performing operations with polynomials in several variables. So lots going on here. For the most part, we're going to be combining and adding for this first one, where we have 3 different terms. Anytime I come across a problem like this, I try to think out what I'm trying to combine. So I notice that there's this y cubed term. There's also a y squared term. There's a normal y term here. And we also have constants. I'm a big fan of color coordinating, so how I'm going to start this off is just by color coordinating what I know I need to combine. So I know that I have a 5y squared here, 2y squared here, another 5y squared here. And the reason I'm color coordinating this is so I don't confuse any of the types of variables that I'm working with. In red, I'm going to use that for the y terms, the 6y, negative 5y, and that's it. Y cubed is going to be leading that off, and we also have constants, which I'll mark in black, just so that I know where everything is. So there's no other y cubed term here, so at this point it's really just trying to begin from the highest exponent to the lowest exponent in standard form. So this has us subtracting negative 4y cubed, which is a form of addition, so definitely 4y cubed is leading the front. For the y squared terms, we have, I'll write this in over here. So for 5y squared, I have that. I'm adding on 2y squared, seen here. And then finally deducting this trinomial here, but I'm deducting a 5y squared. So I'm going to think of this as deducting 5y squared. These 5y squareds cancel, leaving us with 2y squared, which will go next. For the y terms in red, have 6y. I'm then adding on negative 5y, so I'm deducting, and that's it. So in reality, just adding on y. And finally, for the constants, I have negative 3. There's nothing in the middle, but then I'm deducting negative 7. So I should think of this as negative 3, deducting negative 7, taking this further to negative 3 plus 7, which is just 4. So it's as if I'm adding on 4 at the end. Although showing all of this work might seem extra, seem like a lot of work, I'm pretty confident that if you set up your problems the same way, keeping note of when you have signs in the middle and changing those around accordingly, the section shouldn't be too bad. For 2, we have this set up here where we're now multiplying. So I know we're multiplying again because we have parentheses around both of these binomials. This is asking us to multiply, so I'm going to be using box method for this. If I taught you previously in Algebra 2, this should look familiar. And this is just another way for us to multiply. So I know that the one binomial is 5x squared, y, and then adding on 2x. So Those are two terms. So definitely have two columns. We also have 5x squared y minus 2x here. So this is going to also be using properties of exponents, so please keep that in mind. So properties of exponents are coming back into play. If you need a refresher on this, you should have that table from section 3. So going with this, 5 times 5 is 25. X squared multiplying with x squared, be careful here. Adding exponents, getting x to the 4th, and also y squared. Going here, 2 times 5 gets us 10. X squared times x gets us x cubed. Y is along for the ride, because there's no other y term here. Here, negative 2 times 5 is negative 10. X cubed and y. Finally concluding with negative 4x, and we're adding exponents to get x squared. From box method, ideally we end up combining terms that go down the middle. What's nice about this one, look closely. Do you see a pattern between these two terms that I highlighted? Hopefully you were thinking that these would cancel out, which is true because this is positive 10 x cubed times y. This is negative 10 x cubed times y, so those cancel each other. So all we really need to write for this is 25x to the 4th, y squared, and then finally concluding with negative 4x squared. So we're all good with those first two. We'll see the next two in a moment.